really excited to welcome Jen Corbett today, but before I do, I want to just make a couple quick announcements. First of all, Monday, we are going to have a lecture by Zoom and not in this room. It's not only the case that we'll be deluged with snow, but the speaker happens to have the flu, and he's in California, and it's not a good idea for him to travel. So apologies, there's not much we can do about it, and Nicole has everything posted. I think she sent the email around and how you get the Zoom link. So Logan Olson will talk remotely on Monday. Second issue is about the projects. They're all due on Wednesday at 5 p.m. We have all the various presents and things in for winners. Let me point out that the projects need to be PowerPoint slides. I want, and if you have code or if you have games or things, you can link to it, but be verbose. We don't have time to run, in 48 hours, everybody's code or look at everybody's games that they create or whatever they do. So please make it a PowerPoint presentation. Ideally 4 or 5 slides. I'm not gonna, press that, but and we had cases last year where people did great projects, but they didn't really describe. So just put words in there and say, okay, this is what we did, this is what we did, so that we can evaluate it. So thank you for that. All right, so I don't have much biographical information on Jen, so I'll let you provide that. I know that you were at Northeastern. He's at Northeastern. Okay, somebody was at Northeastern. And anyway, are you going to mention the subject of pareidolia? No. Okay. This is a woman who found the face of the Virgin Mary in a grilled cheese sandwich a number of years ago, which is kind of very interesting thing. And I know that you were one of the co-authors on the paper that did that. But anyway, so I've had the pleasure with a couple of my colleagues of having a couple discussions with Jen and her husband Jaap, who's at Northeastern, on issues related to how, for example, human vision is not the same as a camera, and how we perceive the world, all the areas of cognitive science, which actually dovetail very well with the sorts of things that we look at in gaming. I happen to have first noticed Jen's work when my boss posted something internally to SIE on, I think, what she's going to talk about today, which was written up in The Guardian and got an enormous number of people evidently not only reading it, but taking issue with all of the things she had to say. Anyway, so I'll let her take that away. So I'm really pleased to have Jen Corbett here. So let's give her a welcome, please.
Well, thanks for having me. If I gave you my bio, it would just run on forever. Like, I've switched fields, been in many countries, done many things, but I'm basically like a human perceptual and cognitive science with some neuroscience, but at heart, I'm what we call a psychophysicist. And so I'll talk a little bit about that just in some of the stuff that we're gonna do in here. So I'm gonna talk about that Guardian work that you just mentioned. And basically the question was, why do some people invert the y-axis on their controllers in third-person games? And this seemed like a really benign question, right? So they emailed me just for can you consult on this and give us your speculations on why this might happen? And I was like, yeah, perception, cognition. And it turned out that this is a really hot button topic. Gamers are really into this. And so then, that was that, whatever, they wrote an article about it. And then COVID. And then still COVID, and more COVID, and we couldn't go to our labs and do our experiments, and we couldn't get any research done, and what are we gonna do? So we were like, well, let's do a study. So we said to The Guardian, we're gonna actually run a study. We're gonna ask gamers, why do they invert their y-axis? And that led to thousands of emails, just thousands and thousands and thousands of emails. And so it ranged from, I told Mike, crazy things like aliens to really plausible things, talking about we got things from machinists, from pilots, from surgeons, and they really had thoughtful things to say about why they thought that they inverted. And none of those things were correct. They were all completely wrong. And I'm going to tell you how we tried to figure this out. So first of all, what is y-axis inversion? This terribly important thing that gamers are very concerned about. And basically what it means is, if you're playing inverted, that means with your right thumbstick, when you press it up, it's kind of like you're pressing from the back of the player's head, and they look down. And if you're playing non-inverted, it's like you're pressing up, but you're pressing from the front, so they look up. Or you can think about it as like moving the camera versus moving the avatar's head, right? But that still doesn't explain why people invert or don't invert. And so what we did was we asked people, do you always, sometimes, or never invert? So in the audience, how many people always invert if they game? Yeah? All right, how about sometimes? Yeah, these are the rare breeds. And then people who never, ever invert. Yeah, so they're the commoners. But so this is a divided topic, right? And so we thought, well, maybe it's something to do with like trackpad inversion, right? So I am an inverter. I really can't do anything else. Like when I move my finger up, the content moves against me. Little scroll bar goes up with my finger. I cannot use his computer because he is a non-inverter. It frustrates me to no end. And I, like, before we did this study, I insisted, like, I cannot ever do this. I will not ever be able to do this. I was also wrong. That's okay. So what do you think? Like, if you are an inverter or not an inverter, could you change? Do you feel like you could easily change? Or do you feel like, no, this is really what I do? I know some of you really feel like you're not going to change, and other people are kind of more, right? So some gamers really are insistent, like, I cannot change. This is the way I game. I'm built this way. And so The Guardian also thought, like, maybe this is a hardwired, like, neuroscientific thing, and, like, that's why they asked us. Well, we asked gamers, so why do or don't you invert? And so what are some of the possible things that you think that they said? Because they gave us really good reasons. Anybody have guesses? Yeah? Feels natural? Why? But why might it feel natural?
I think maybe because of my previous interactions and mental model I had from.
Beautiful. We got that one a lot. It's the first game I played. It's the first gaming system I played. It's the last game I played. It's my favorite game. Stuff like that. Anybody else? There was one glaring one that they just would not stop telling me.
If it feels like you're on the opposite end of a pivot point, which you are, it would make sense that the other end of that lever should go the opposite way.
What game might have done that to them?
I can think of like any game that has turrets would be good.
They were overwhelming about Flight Simulator. They would not stop emailing me, you don't even need to do this study. I can tell you what it is. It's Flight Simulator. Why are you even bothering with this? It's a clear answer. Like, they were relentless, just relentless on this. We also got things like, it's scrolling, which we thought was logical, right? It's the first game I played was a big one. Like, I started playing this way, and I just couldn't learn to play it. This is just how I got set up. Or it's the first gaming system I used was a big one, right? Like, this is the way that that system was set up, so this is how I learned to do it. Then we actually tested them. And so we got thousands of responses, but it's really hard to get gamers through like a proper experiment, especially when you have to do it over Zoom during COVID. So we ended up with like what I think was like 170 full data points, which is really a lot. And so when we actually tested them, none of the reasons that they gave had any predictive value, and a lot of the stuff that we thought wasn't predictive either. So we kind of used some machine learning to kind of pull out the features that had the maximum explanatory power, and then some other machine learning to kind of rank the importance of those predictors. And so what you can see is like the first game they played, no predictive. The favorite game, sorry. The first system that they ever used, nothing predictive. Flight Simulator. Nothing predictive. And I'm a little smug on this one because I got so many emails telling me how it wasn't necessary to do this work. And also scrolling, which we thought really should have a relationship, but it doesn't. And so neither did, surprisingly, typical user experience measures. So typical user experience measures in these situations are usually like assessing someone's feeling of presence as the avatar or someone's general sense of immersion in the game. Right? And it's important because the only other study that's ever been done on y-axis inversion was done by a group that found a correlational relationship between these factors and inversion. But importantly, their study actually looked at a representative sample. Like, they didn't go through The Guardian and say, like, we're going to study inversion. So we got an overwhelming response from inverters, right? 2 times as many inverters as non-inverters in our study, but in the real population, it's like 7 to 12%. So they kind of looked at the real population. They found this relationship. We found no such relationship when we looked directly at inverters. Neither is right or wrong. We're not proving anything. We're just doing correlational investigations, right? So we're just looking into this now. And so here are all of the, I think there were 28 total factors we ended up testing after narrowing down all of this input that just kept flooding in. And so I'll talk about these later, but I mean, that's something that you'd think would be age, right? Or something that happened historically. Because what we do see in the literature, in the HCI literature, is a change in people's trackpad and mouse scrolling directions from the 80s to the 2010s, and that had to do with changes introduced by things like Apple's kind of natural scrolling, probably, right? So we thought that would be something, but we didn't see any kind of predictive from age or the number of years they spent playing. We didn't see anything having to do with other things that we thought might be really important. So yeah, we were wrong on a lot of aspects too. We didn't see anything about their handedness, left or right, or ambidextrous even. We didn't see anything about, a lot of gamers told us that they switched at some point. They used to play one way and they switched to playing another way. And that was also an overwhelming response. We were like, this is cool. Maybe there's something that made them switch one way or the other. But it's just random. There's no one way they all switched together. There's no pattern of games that they played that got them there either. But it is cool to think that, so they can switch. We also looked at their favorite game, like I told you, no predictive value. We looked at gender, nothing there except for we see that females and non-binary people are greatly underrepresented in gaming work. We also looked at the genre that they played. This might have something to do with it, right? But nothing there. We even looked at, many people own different kinds of consoles. So we looked at, what combination, do they have PlayStation, Xbox? Are they a PC gamer? Is it Nintendo? None of these systems or combinations of them had any predictive value. And then, no flight simulator, 0. Look at how low it is on that list. And so not even scrolling. These are things that we were wrong about that I'll talk about, and none of those user experience measures or any of subscales on those. And so that's important too, because in user experience, how these things are typically assessed are using those sorts of measures. So what do? Well, you ask gamers. We did that. We got a lot of input. But typically, you use surveys and questionnaires. And that's what these immersion and presence things are. They're like 100 questions and you rate on a scale of 1 to 7, how often do you lose track of time when playing a video game? And there's supposed to be a bunch of questions that kind of tap into the same construct. They have convergent validity, we call it. And so you get your final score of this, and that's your immersion score. And then there's different subscales that can kind of look at different aspects. And that one previous study I'm talking about found some differences in there, but it wasn't really clear why, right? So you can use surveys, and you can ask people to directly give you a number for things, right? So tell me what your number is. And you can also use testers or focus groups, right? And so this allows people to kind of directly tell you, I can sit here with some of you, and you can play inverted or non-inverted and tell me why it feels weird and what. But that's great, but what if it's something else? Right? What if it's something different, which is why I have a job. So good. So why is behavior so important? And so just like we use physics to kind of get at latent things that we can't directly measure, right? We can't directly go and touch some things. So we use physics to kind of infer their properties. And it's the same with psychophysics. I can't drill into your brain and look at your cognitive processes. I can't do this with neuroimaging. That's not how it works. So I have to infer how these cognitive processes, these latent states, are happening based on your behavior. And so another huge obstacle is we're humans and we're very stubborn. And we really think that we know why we prefer things. And even in this case, if we're proven wrong, gamers are still telling me, but for me, it's Flight Simulator. I promise you, for me, that's what it is. So even when you have evidence to the contrary, people still insist. And another important thing is sometimes we literally cannot understand why others are seeing things differently. And that's what gamers are telling us. There's no way I don't understand how anyone would play inverted. It makes no sense. It's just not a way that you can actually play. It's not a real thing. And so a good example from my field that we kind of got sick of talking about, but makes a good point here, is what we call the dress. And so how many people see this as blue and black? Normal people. How many people see it as white and gold? Yeah, and it's crazy, right? And so a fraction of people can see it both ways. But for the life of me, I cannot understand. I can understand, like I know why this happens. I'm a vision scientist. I know it's about like the illumination and whether you perceive it as indoors or outdoors from your previous experience. But I still can't understand how people can see it as white and gold. I've never been able to see it. I'll never be able, it's just, I can't understand it, right? And if you measure the wavelengths coming out, it's black and gold, and it's black and blue. I don't understand, but it happens. So maybe it's an issue like that, right? And so when we look at our top 3 predictors, what we see is that we kind of still need some common sense here, right? So we have this one that we put in there, the most recent game that people played. Maybe there's a game that's just like flipping everybody, pulling everybody over to the inverter side, something like that. But even when we looked at that, there was no single one game that could have done that, right? So basically, we were just looking at like, do you invert or not? Well, I'm playing this game and I'm inverting on this game, so obviously that's gonna correspond with the answer, right? So it just kind of shows you that like, even if you're using a really good machine learning algorithm, you still kind of have to have some common sense in there to evaluate the output. So what really predicted the inversion preferences were these 2 cognitive factors. And here, this is important because it's really difficult to be aware of these things, and sometimes it's impossible to be aware of these things. And that's why we have to measure them with behavior. So I'm going to show you what we did, some examples. And so in this first test, I'm going to show you 4 shapes, and you're going to tell me which one is a rotation of this shape. 1, 2, 3, or 4. Shout out the answer as fast as you can. And by rotation, I mean like not kind of flipping it, but just rotating it. All right, are you ready? All right. Yell it out.
1,
2.
4.
See those staggered times? All right, there's the answer. Let's do it again. I should collect data in here. All right, ready? 2. Okay, faster that time. One more time.
1.
All right. So on this task, it turns out that the slower people were at doing it, the more likely they were to invert. But they were also slightly less accurate. So it's not like they were better or worse. They were just different, right? And so if I asked you in a survey, like, how fast do you mentally rotate on average? Is it 600 milliseconds? Is it 650 milliseconds? You can't tell me that. I need to measure that with your behavior, right? We also found another important predictor, and I'm going to make you do a bunch of tasks, so you just have to do them, or I'll just stare at you until you do. So in this task, you're going to put your hands on the E and the O on your keyboard, right? So E and O. And some of you will really feel this one, and some of you will feel it much less, but it's a little bit more noticeable. And so I'm going to show you a number on one side of the screen, and there's going to be an X on the other side. And you just pay attention to that number. And you tell me whether that number is even, you press the E key with your left finger, or odd, you press the O key with your right finger. And you do this as fast as you can, but you need to get it correct, because we're measuring correct reaction time, because everybody knows whether something is even or odd, right? All right, so we're going to do it. Ready? Yeah? All right, another one. Another one. Another one. All right. For those of you doing it, I see reactions. And so for those of you that did this, you kind of felt like we were going fine. Like this was kind of easy. All of a sudden it got hard. So these kinds of trials weren't difficult because what happens is you have the number on the same side as the correct response. So here, 8, even, response, left, E, right? Here, 3 is odd, the response, and it's on the right, and the response is O on the right. So you have like compatibility. Your stimulus and response are on the same side. And here, where some of you who are doing the task, like you're like, whoa, all of a sudden, now they're not. They're incompatible. And of course, you can do this task, but it takes a little bit more effort, right? Because here you have an odd number on the left side, but you need to respond with the E on the right side, or O on the right side. And here you have an even number on the right side, but you need to respond with the E on the left. And so this is stimulus response mismatch, right? And so gamers who were able to overcome this mismatch, who weren't affected by it as much, were less likely to invert. So this was another really predictive thing. We were like, oh, cool, we figured some stuff out. But when we looked closer, like we were really just scratching the surface, and there's so much more work that needs to be done here. Because there's extremely complex interactions, and they're not understood across multiple fields. So just to kind of break it down, what you have in general is a stimulus, a target out there in the world, and we're going to use this blue cube as our target. And then you have a response that you're making through an interface, the controller. And that has an effect on the avatar in that 3D environment. The avatar does something in response to that response, right? And so not only does the side of the response and the stimulus matter, like we just saw in the previous demonstration, right? So you can have stimulus-response compatibility. The target's on the left, I'm going to shoot it with my left controller. But you can also have incompatibility, like we just talked about, where the target's on the left, but now you have to shoot it with the right. And you'll be somewhat slower, even if you don't notice it. But you also have what's called response effect compatibility. And that's the issue that gamers were initially raising about the right thumbstick, right? And I'm going to talk about the less controversial left thumbstick in this example. So what you mean here is that when you press the left thing up, your player moves forward, right? It moves in the direction as the body part is moving. And what it means to be incompatible or negative response effect compatibility is when I push forward, you actually move back. So you move opposite the body part. But there's more. There's also something that no one ever considers. It's really hard to find anything about this in any literature. And that's called stimulus effect compatibility. And it's surprising, because that simply means, are you moving towards a target, or are you moving away from a target or an obstacle? And this is really important because we behave very differently in these situations. And it's even more important because these things interact differently for every single person. One person might play better inverted if they're moving towards something, but also if their display is flipped in a certain situation, they might do better, but they might not do better avoiding a target that way. So it's really, really complex, and it seems pretty overwhelming, and how would we ever figure this out? But I mean, honestly, it's pretty simple if we just do some simple experiments measuring very, very basic things like reaction time and accuracy. We can map out these relationships for a given gamer quite easily from doing that. We can kind of start to classify different things like moving towards targets, moving away from targets, looking at an inverted map view. Maybe you play a helicopter simulation because you have to do something, and then you go back to your regular control scheme. We can measure these patterns of behavior, and then we can get to know about the individual. And like, I mean, we hear human in the loop all the time, but in this case, humans really actually are the loop here. We're driving all of these effects, right? And so I think this is an important point, because humans are not algorithms. We are not computers. We do not behave at all like computers. I am the person that runs around this building all the time screaming about this. But like, we don't have hard set rules. There's no 0-1. There's no function that will give you the same answer every time. Right? If I show you those things that we just did, those mental rotation things, you might give me the same answer every time you see that exact same slide, but your reaction times will be slightly different, right? So our behavior has variance. We're not algorithms. We're not deterministic. And so every single time, we're going to respond slightly different. What we do is we use heuristic behavior. So we use general strategies or styles in doing things. And so we kind of have these average behaviors, which is why my experiments are so long and the computer scientists get mad at me, because I make you do multiple trials of the same thing so I can average that together and then put like quantifiable uncertainty around it. So like an average and variance, right? So biases are basically the same thing as heuristics, but when they're working well for us, we call them heuristics. And when we don't like it, we call them biases. But it's the same idea. And so these things can be hardwired in a sense, or they can be learned. And I always give handedness as the same example here. Because back in the day, like boomers and beyond, we're kind of taught a lot to write with your right hand, even if you were left-handed. You had to write with your right hand, no matter what. And so people were fine with this, and if you ask people who this happened to today, they'll tell you it's fine, I learned, I do it just as well, I've totally adapted, there's no consequences to it, it feels completely natural. But if you look at the literature, there's a rich literature on all of the detrimental effects this has had in terms of cognitive abilities, handwriting abilities. If you look at some of the neuroimaging data, these people are actually like working harder, even though they feel like they're not. And they'll tell you they're fine, but they could actually be doing a lot better if they switched back. And of course, if you switch back right away, you're gonna write really weird with your left hand at first. But if you keep at it, you'll start to see performance benefits and neurological benefits. So maybe it's good to make a change if something isn't working for you, even if you don't know it's not working for you. And that kind of brings me to my big point about like, what do I see as the future of AI in gaming? And so personalization is such a big deal, right? We can personalize so much stuff. Like we can personalize already by selecting the games that we want to play, right? But we can personalize what kind of character we are, what role that character has in the game, what that character looks like, down to the very last detail in some sense, right? But we can't cognitively customize. And like for good gameplay, that's like so much more important than what hat your character has on, right? If a game could adapt to your kind of cognitive processing abilities, like your stimulus, response, and effect kinds of compatibilities, then your gameplay might drastically improve or simply become way more enjoyable. But it doesn't stop there. Like this is just, so we need to do this work, but there's so much work for decades probably to do beyond this as we go further into AI. Because what about things like working memory capacity? Some people could just hold more in their like short-term store than others. Like I have no short-term memory. I'll forget what you tell me like 10 seconds from now. Or what about cognitive load? So some people can't really do many tasks at once. They can't really multitask very well. Some people are really bothered by like clutter, visual clutter, right? These have like large effects on some people, not so much on others. I think Leanne's talk on Wednesday kind of touched on this, but like the way that you allocate your attention around the display. So she was showing like experts tend to look more in the middle of things, whereas novices tend to look right at things. And that's like an expert-novice difference, but like, wait, there's more. Like people have just general different kinds of styles. Like some people just scan naturally, and some people like drill into the details right away. So it's a big difference in style and how you kind of look at images. Things like mental rotation ability, we saw that, right? And processing speed, and that's a really important one that I want to come back to. But really, again, this is just, I mean, there are so many things that we can look at cognitively that can be integrated like this. So what are my recommendations for gamers? I mean, this should be kind of obvious by now, but try doing it the other way. Just try it, just try it. Why not? Just try it. You have nothing to lose. Like, you know, don't do it if you're competitively game playing for the first time or something like that, but just give it a try. And I mean, the important point here is stick with it, even if it doesn't click at first. Like if you're writing with your right hand your whole life and you're really left-handed, it's not gonna feel good the first few times, right? It's gonna feel weird, but it still might be better. You still might see long-term improvements. And I mean, try different inversion patterns in different games. What we really saw, like, and I'd love to investigate more, was this like minority population that's sometimes inverted. And they were, their measurements, it looked like they were just so much more careful and detailed about like their gameplay, right? So they had different patterns than anybody else. And so I think this is something that really speaks to like, try it differently in different ways in different games, because one situation might not work the best in the next situation. And if we had a way that we could learn an individual's cognitive profile like this, maybe we could make it so that it could be transportable across different games, right? And so you kind of learn from one game and you go to the next game and you start learning more in that game, but it's not really working in that game. And so you kind of learn the new profile or you update the profile from that game, right? And my recommendations for game designers should also be pretty explicitly clear. Start measuring reaction time and accuracy. Simple data to get, very easy data to get. Hopefully we're gonna be able to do something like that in the near future. But I mean, we can kind of map out different tasks, different actions. Like this is a fight sequence. This is when I'm reloading. This is when I'm avoiding an obstacle. This is when I'm going towards a target, away from a target. Things like that. And we can kind of measure the speed and accuracy trade-offs or relationships in these situations. And then we can relate these to known cognitive abilities, right? So we can kind of go back and forth like this. And then we can kind of track and adapt to a player's cognitive abilities and their changing cognitive abilities. And so that kind of brings me to something that I do want to talk about, because I was talking to Mike, and gaming gets a bad rap, right? So once upon a time, there was this study that was like, violent video games cause violent behaviors. And it's like, so when I teach research methods, I always used to use this study as an example of like the worst study ever done. Because it was a correlational study, which has no means of showing cause and effect. And every single thing they looked at correlated with every other single thing they looked at. It was the dumbest study ever, and it was just so frustrating. And I would always explain this, and then one year I had a student raise their hand, and they were like, that's my uncle. It's like, all right, I'll just talk about like the good studies that were done that are like nice peer-reviewed, scientifically backed studies. But gaming actually shows us real improvement in real life, and especially third-person gaming. So this is just like a handful of things. There are so many. But gaming actually improves attention and processing speed. And that's important because our processing speed declines as we age. So like my friend here was saying, like, you know, I don't play first-person shooters anymore because I'm just not fast enough for these snappy kinds of things. But then he's, well, maybe if I did, I'd actually get better, right? You see improvements like this. And not from just games, and not from board games, from 3D third-person games. We also see improvements in memory, right? We see improvements like behaviorally, but we also see these in neuroimaging studies. We see improvements in executive functioning and mental flexibility, right? We see like that kind of inhibiting that wrong response. You get better at doing that. You get better at like filtering kinds of things, right? So these are all real-world life benefits from playing video games. So not really detriments, but benefits. And so while games have a lot to learn from our cognitive patterns, right? Like I've been telling you, our cognitive patterns have a lot to learn from games. And that makes kind of another important point, because often games are used as training. And these questions that we asked about games overlap with so many different fields, right? Pilots have to sometimes use inverted displays from what they're used to. Surgeons have to use inverted displays and instruments. Some mechanical operators have to use inverted equipment, displays, things like that. This spans so many fields, and we heard from so many different professionals on this topic. And so just taking the example of gaming as training, which is a common thing done in the surgical field. And so if we learn these things, we can kind of mutually inform each other. And so I give the example of laparoscopic surgery, right? So here you have two surgeons on either side of a patient, and they're wearing masks. And so you have the assistant here, and then you have the operator. And then you have a camera. And the camera is the only way that they can see what's going on inside the patient, right? Because their instruments go in. It's minimally invasive like that. And so here's why I think gamers can totally get over it. And I don't know if these go up on YouTube, I'll get another slurry of emails about this. But really, you can get over this kind of mismatch. So surgeons have to deal, naturally, laparoscopic surgeons, with response and effect negative compatibility, right? They have to naturally deal with inverted controllers. And so what you see in their literature is when surgeons start out, they complain about this. They really hate it. They have to overcome it. But the learning curve is like so steep. Immediately they overcome this because they're forced to do it and stick with it. And then experts will tell you overwhelmingly, there's no way I would do it without inverted controls. There were some attempts to kind of make things differently so you could, and experts just hated it, right? They're used to the inversion now. It's the logical way it works for them. So probably gamers could get over this. But what people can't really get over sometimes is when we have that stimulus-response mismatch, that thing where the number was on the one side or the opposite side. For some people, that's really hard to get over. And so this is a problem in surgery because here you see the camera, it's always positioned where the operator is. And so the operator has a correct view of what's going on inside, right? They know that if they move their inverted instrument, it's going to go the way that they're seeing it on the screen. But the assistant has a reversed display. And this is really problematic, right? And so their literature shows that it takes something like, I think, 83 surgical sessions, so it's a really shallow curve, to overcome this to a level of clinical competency. But even then, some people can't. And so there are ways that you can change your setup to kind of make it so the assistant can see the display properly, but these are really expensive. And sometimes they're not even possible in a given facility. So quickly assessing this, I mean, if someone's really not gonna be able to get over this, this is not somebody that you want as your assistant, right? So this could be a good like health and safety kind of assessment too. And so that's kind of what I mean by like, they tell us stuff, we tell them stuff, but all of this stuff is unknown. It's not put together across fields. There's no stimulus response effect compatibility kind of relationships that are really mapped out. So this is something that's relevant across so many domains, and it all started from gaming, and maybe the answers will come from gaming. So that's all I have to say, and I want to thank you very much for coming out, and I want to thank my co-author, Jaap Munnicke, who is like our avid gamer. He's a weird PC gamer that like uses keys, and like he has a PlayStation 4, but it's only 4, it's not 5. So, and then this is our lab if you want to know more about it. Here's something I think is really cool. If you want to dig into this data, because we collected a massive data set, here it is. It's open source, go for it. If you have questions, email me. And I mean, maybe you'll find something new. There's so much data in there, right? And then finally, if you'd like to know more about what's going on in my lab, I'm begging you to please run in this 3-minute study. We're trying to make diffusion models more artistic. Please give us your data. We'd really appreciate it very much. And I'm also looking very much forward to seeing your projects. I talk fast. Yeah?
If you look at professional players in like the esports realm, do you see kind of if you look at like the esports area and you look at kind of the leading gamers in that field, do you see a discrepancy of like if many of those players are inverted? What are the percentages? Because I think you mentioned 7% are inverted.
In the like general population, like 7 to 12. I haven't had the opportunity to look at expert esport players. I think maybe Leanne has like some opportunity to do that. But I also think that they have a lot of nuances. Like I'd imagine that, well, I don't know, I'm speculating. I'd imagine that they're more likely to sometimes invert, right? I think it's definitely gonna have a dependency on the type of gameplay that you're doing and even maybe your opponent's gameplay, right? Because if we can adapt games to these sorts of compatibilities, and that's where I think this also has a big impact, is competitive gameplay. If we can adapt, like just for the average gamer for these compatibilities, then if competitive gamers can do it, maybe they're already doing it and they don't know. But that would be an amazing thing to kind of dig into further. Leanne and I are gonna do something together, so maybe we can do that. Mm-hmm.
Yeah, very interesting topic. So I have a more general question about your study design and how you look into cognition. So, because I can imagine for some of the interactions are more like embodied, especially for like virtual reality interactions. So do you consider like embodied cognition, or you're looking at cognitive load theory? Like what is your perspective and theories on that?
I mean, I think we're considering all of those sorts of things. But if you're thinking like, so we're considering kind of a special case of 3D games, right? And so these problems are not that, some of these problems may exist in different forms in things like virtual reality, but we're talking about now having a 3D environment where you're accessing it through an interface that's not directly comparable to your body part. Like I'm not moving around in VR and my hands do what my hands do. I'm trying to move an avatar around with a thumbstick, right? And so those mappings are much less clear than like just being in virtual reality, which has its own problems, of course, but it's much more like embodied. Like you have obviously like a natural sense of presence because you are in virtual reality, right? So, but I mean, it would also be really interesting to look at those differences because those differences can give us a lot of insight into how best to kind of align to both those types of gaming.
There's also like this space of like, for example, improving your body, like extending your body with, for example, more hands or like different embodied presence. So I was wondering like for example, yeah, I was working on a project with when you had technically 4 hands and you were interacting, but
the different objects through your forehand. So I was wondering, like maybe virtual reality can be a window to experiment with something.
Yeah, I mean, I think, do you have a specific example?
No, but I mean, I think what you're saying is absolutely correct in terms of like, what can we learn from interacting with 3D environments through various means, be it a control or be it virtual reality. I mean, these kind of tools, I think, are just like candy stores for cognitive scientists, right? Where you can just grab what you want, and it really depends on the question that you're trying to answer. If you want to learn everything about, what it is to interact with 3D environments, then VR is absolutely a route to go. We did this over COVID, so we only Zoom.
But I mean, in Immersion Lab, I mean, I know that they look at things like, I mean, how can we make the workplace safer in like assembly lines, things like that. If you do it in VR, like you're not going to get your hand crushed, right? So, I mean, you can look at these sorts of things and how little tweaks and improvements can help you in different scenarios. Like ours kind of apply to a different class of problems in some sense where you have to deal with inversion, whereas in VR, you might not necessarily have the same problems, but I think both of these are like huge, like gold mines for kind of cognitive psychologists and scientists, yeah. Yeah? I have to wait for it.
Thank you. Nice talk, Jen.
Thanks.
What's your hypothesis in terms of haptic feedback? So it's still on the joystick. Say your mental model was there was a virtual spring connected between the joystick and the thing I'm moving. Would that change anything?
Absolutely. I mean, it definitely is going to have different effects for different people. Like some people are going to respond more strongly to it. But I think like haptic feedback can only add to the experience, right? But if it's discordant with visual feedback, it's going to be problematic. Right, so we as humans, like haptic feedback is great and it can only add to the game as auditory, as anything like that. But we go with our visual like gut first. So the visual display is what really guides us, right? If I tilt the world, all of a sudden you'll come to think that that's your new upright, and things that are actually upright will look tilted to you. So if you have haptic feedback that's in accord with the visual feedback, I think that would add an extra level of enhancement. But I know we're adding it now, and I know that people really like it. Like I've heard from a lot of people that they really enjoy like the haptic feedback from the controllers, and it's really helping them like kind of sense when things are going to happen, and it works for a lot of people. But if your stimulus response and effect compatibilities aren't really kind of fine-tuned yet, then adding haptic feedback that doesn't really work with your profile might actually be detrimental. We'd have to measure it.
Right. So then what would the likely, do you have a hypothesis, would that lead to less inversion? Like if there was a natural, like if the game enforced a certain, well, I guess it depends. I mean, if you enforced a certain haptic feedback, that might force you to the invert or not, as opposed to being able to also flip the spring, if you will, for the haptic feedback.
I mean, I think there are special circumstances where I would say that it probably would. Like I would hypothesize that it would. Like if the haptic feedback is something that is like in the same direction as you'd press instead of like an inverted direction, then I think that you'd probably be less likely to invert because you're reinforcing that behavior. I don't think that you change non-inverters into inverters or vice versa doing that because they're very set in their ways. But I mean, I think if you're just starting out as a gamer and you made it so that it was congruent with one direction or the other, then people would start to pick up on that as a guidance, yeah. He can ask me at home. Did you want to add to it, did you say?
Yeah.
I'm sorry, he was going to add to it. I'm sorry. Bad partner.
I can speak loud, I guess.
Go ahead.
Go ahead.
So what I'm thinking is, I think haptic feedback is probably more mediated than anything else in this system, because we know that if you do it right, haptic feedback, it kind of sort of adds to the experience, right? And so immersion levels might go up because of it. And we know from that one other paper that immersion does correlate with inversion. And so in that sense, it could potentially do what you say. That would be, I think,
It would have to be very specific, like not just general haptic feedback. Like.
No, it needs to be like probably integrated with events that happen on the screen. That's sort of like some multimodal integrations going on. And then it probably could do that.
Following up actually on Brian's question about not just haptic feedback, but I'm also thinking sound, so multimodal feedback. And the question arises in my mind first from a different angle. especially now, the area that I work in is in manufacturing. One of the things that we are working on are digital twins.
Yeah.
And how people navigate digital twins, but also then are being used to control machinery far away from where the operator is. And so this is fascinating from that perspective of correct movement between operators being so important, especially the safety in a plant or in a mine or et cetera, right? And so I'm curious if you've looked into how multimodal feedback gives or not greater accuracy of movement or suggested movement that the operator wanted to do. That's kind of a much broader question.
Well, I know Brian's asked me questions along these lines because he said that like operators can kind of sense like from the general auditory signals that something is off, right? And the digital twin won't give you that per se. But I mean, I don't have auditory expertise per se, but Mike was also saying that there are now games that have like these kinds of sounds that kind of guide you and push you through a game that kind of give you this extra layer of signal. So I think it's kind of like with the haptic feedback issue, if you have the user's kind of basic like stimulus response effect compatibility profile mapped out, and then you can add that multimodal feedback to enhance it and not go against it, then I think it would boost a lot of things like immersion, like presence, like enjoying the game, stuff like that. But I think that before we start asking, these are great questions to ask, and I think we should keep asking them, but I think we're going to be in a better position to answer them when we understand the fundamentals of the visual information that is generally much more important, even though we feel like all these things are going to add to it. If we don't understand that foundational thing that we're going to go with above everything else, then we're not really going to understand the best ways to do these things. But I'm a scientist from that. I'm not an engineer, so that's how I would do it. But it does, I'm sure, have value for sure.
Yeah, just so apropos what you're saying, in the AAA games, the sound engineering, the games that we make at PlayStation are extremely elaborate, and the amount of thought that goes into how the music changes as the character moves from one place to another, or as the monster approaches, is really it's an art, and it's done a lot. I have actually one very trivial question, actually. So I'm still, after only a few years at PlayStation, a novice with games. How many people just simply don't know that they can invert
Many. That's one of the things that we wanted to point out. Like, I mean, so people don't even realize they can go into the preferences and change this stuff. Like, and that's why it's important for designers to think about like, what are the defaults I'm going to put into this game? Or do I even like, because experienced gamers, they're going to stick with what, there's no swaying them, we're not going to do this for them. But if you had something that popped up for like newer generations, people who are just starting to game, like, do you think like you can try it this way? You can try it this way. I think Halo has this one like tactical station where they kind of do a quick measurement and tell you whether or not you should invert or make a suggestion. But it doesn't really seem to be like super effective. But if you could really like say like, here, do this quick tutorial and we're gonna map this out. Actually, you would play best inverted in this game, we think, try it out. Or you would be playing best non-inverted. Instead of just saying the default is non-inverted, if you want to, go in and change it, right? Because you're not gonna do that when you're just starting out. You have no idea. So I think it would be a great thing to add or integrate somehow.
Can we thank Jen again?